Sorry, we just got a few people coming in and I just want to make sure we let them in before we begin. Okay, I think that's everyone for right now. So hello and welcome to Diggin In. I'm Lindsay Randall, the host of the speaker series. And Diggin In is a series of live presentations with archaeologists from around the country, co-sponsored by the S. Peabody Institute of Archaeology and the Massachusetts Archaeological Society. Today is our last episode for season 1, and we hope you will join us on Wednesday, January 27th for the start of season 2. We have some great lectures lined up from privies to Comanche rock art. Viewers are able to submit questions directly to me via the chat function on the side of your Zoom screen. And at the conclusion of the presentation, we will give our speaker time to answer as many questions as they can, with the understanding they might not get to all of them. And today we are excited to conclude season 1 of Diggin' In with Miss Jennifer Ort. Miss Ort, her archaeological experience began in the White Mountains of New Hampshire at the New Hampshire State Conservational Rescue Archaeology Program in 1996. And over the course of the past 20 plus years, Ms. Ort has worked in the cultural resource management sector before recently changing careers as an archaeologist working in government services for Horn LLP. Ms. Ort received her MS from the Climate Change Institute at the University of Maine-Orono in 2012, where her research focused on an intensive analysis of Brook 1 site under the guidance of Dr. Brian Robinson. Welcome, Ms. Ort, and thank you for joining us today.
Hi, everybody. Thank you for being here. I apologize. I've had a cold for about a month, so I might sound a little scratchy, so I apologize for that. Thank you all for coming. Thank you, Lindsay and the RS Peabody Museum for inviting me. So I guess I'll just get started.
Yeah.
Let's jump right in. Yeah, let's do it. All right. So I figured I would do the talk as kind of, if you've never heard of the site before, let me tell you about it, and then a little bit about the research I did for my master's, and then I'm currently a PhD student at the University of New Hampshire in their Natural Resource and Environmental System Science program. It's a mouthful, where I'm continuing my research on the Brook sites, so I'll introduce some of the research I'm planning to do for that. So with that, I'll get started. As many folks might know, paleoindian sites are typically characterized by dense tool concentrations or loci. These are typically, sorry?
Jen, you're not sharing your screen.
Oh, I'm not?
No.
Oh no. All right, I'm sorry about that. Let's try that again. Where am I? Share screen. There we go, this one. Share.
Yay.
There, huzzah! We can do science, just not computers.
Yep.
Okay, how's that?
Perfect.
Yay, all right. So, here we are, diners, drive-ins, and caribou dives. I need to move this guy so I can see. There we go. So anyway, so paleoindian sites are typically characterized by these dense tool concentrations. We also call them loci, and these can be related to either long or short-term occupations, and also repeated occupations over time. In fact, we have some recent excavations at the Tennant Swamp site in New Hampshire that kind of give us an idea of what internal characteristics of these loci might look like. Ethnographically, these are not uncommon. People gather for all certain reasons, for time periods, for what activities are taking place, and the size of the group. We've also seen activity patterning in many sites in the Northeast. It's just that Brook still remains the largest and most highly structured in North America. Now, the site was discovered in 1950. The property was purchased in 1949 to be a sand and gravel pit. So on the left of the screen, you can kind of see what it looked like. And this is one of, I believe, Nick Vaccaro's photos of the landform as it looked before it was destroyed. And then, of course, on the right, we have active graveling occurring. Now, the property itself had actually been known for many years as a place for collecting, and it had a lot of archaic and woodland period artifacts collected, but no one had ever found anything from the Paleoindian time period. And so in 1950, Joe Vaccaro found the first fluted point in a recently bulldozed area. So then between 1951 and 1962, with the principal excavators of Bill Eldridge, the four Vaccaro brothers, Joe, Nick, Frank, and Tony Orsini, and Billy DiPaolo, they excavated both sites. And some point, I believe in 1956, they were going to put an electrical tower over near where Bulwark 2 is located. And so the guys went over and they checked it out. And sure enough, they were finding materials that were very similar to the larger site. So the Bulwark 2 excavations are kind of wedged in this time period as well. After the excavations were completed, the group continued to meet for some 30 years at Nick's house. They called themselves the Paleo Club. Nick built a special shed for them to meet in. Nick himself became an exceptional flint napper, and Bill, the principal record keeper, ended up working at the Peabody Museum, convinced the group to donate their collection, where the bulk of it remains today. And he maintained a relationship with the museum up until his passing in 2009. So now let's look at the site. So you can see they're located on the similar landform. This is a flat landform that appears to be proglacial terracing, sorry, words. What am I trying to say? Delta, thank you. So it was nice, flat, well-drained soils. It was probably about 40 meters above modern sea level. So I don't know if you can, there we go, I can do a laser pointer. So here we have the larger site. It consists of a 36 loci, and it measures about 3 acres. The smaller Bulwark 2 site is located just here on the edge of the landform, and it was 7 tightly clustered loci in a more of a linear pattern. And then today the site is surrounded by Holocene salt marshes that were likely established between 4,000 and 2,000 years ago. So when I worked on my master's with Brian, we identified concentrically organized activities where the interior loci were dominated by bifrost production, drills, flake shavers, and the interior were flute flakes, and sorry, I'm getting backwards here, I apologize. Exterior was dominated by processing tools. So the tool distributions show that point manufacture activities were dominated in the interior while processing was exterior. Panel flakes, which are waste products from point manufacture, comprised 84% of the interior loci. And considering that's only 6% of the total artifacts, that's 15 times more flute flakes recovered from the interior than any place else within the ring itself. So these activity patterns were then, are indicative of the site being used as a communal gathering, believed to be centered around a communal hunt of migrating caribou. Now, the very different Bulwark 2 site, while temporally related, we had similar tool types, although we were lacking drills and flake shavers, and we also had very similar lithic materials, although not at the same distinction that we had at Bulwark 2. We had some differences that were going on, but all still basically coming from the same location. It's located along this boundary fence here. So this is Bill's original map during the excavation. This is from the Grimes 1984 publication that I just did some Photoshop on to make it a little clearer. And then while it lacks the tool diversity, Locus A at Bulbrook 2 does look like a biface dominated interior at Bulbrook 1, but overall Bulbrook 2 looks like our typical Paleoindian sites in the region of repeated occupations over time. Of course, we can't do a presentation without showing the beautiful artifacts. So on the left here, we have these are Bulbrook 1 artifacts, and these are what were used to do the analyses. These were the tool forms that we used for both sites. And then the materials that we confidently identified to a source. So we have Munsungan in northern Maine. We have the Jefferson rhyolites. We have local rhyolites here, Pennsylvania jasper, and of course our Hudson Valley cherts. And there's of course numerous other types of material that are present, much that we could not confidently identify to any of these sources. So why was this site so attractive? Why were people here? What resources would have been present at the time of the site's occupation, since we know that that salt marsh came much later? And then how does this affect settlement patterns that we see between the two sites? So when the site was occupied, sea level was some -60 below modern sea level. So we're going to be right here in this little red circle. Today, the sites are located within a mile of the coastline. So we can see Plum Island here. But when the sites were occupied, it would have been 18 kilometers away. So that's quite a distance. So we're certainly not looking at coastal resources as an impetus for occupation. Now, the previous study strongly supports the communal hunt theory for Bulbrook 1, but for it to represent a large aggregation, a substantial food source or the promise of one had to have been present. Caribou, as we know, is one of the primary resources exploited by Paleo-Indians and has been identified within the Bulbrook collection. So this submerged topographic feature here that's known as Jeffrey's Ledge could have supported a caribou refugia, suggesting the site was situated as a highly predictable intercept point as they came ashore for their winter dispersal. Additionally, whether to support a large aggregation or the smaller occupations represented at Bulbrook 2, other resources had to have been present. Since the creation of the salt marsh occurred through the Holocene sea level rise, surrounding environs were likely woodland or meadowland, and these environments could have supported smaller fauna, including freshwater shellfish, anadromous and catadromous fish, migratory birds, smaller game, deer, beaver, etc., as well as rural resources used for both subsistence and for raw material acquisition. So the convenient juxtaposition of these two diverse settlement types provides an essential focus of comparison between different scales of occupation. Portions of Bulbrook 2 may still be extant, and we are planning new excavations to try to determine if there's anything left. So with all of this on the plate, what do we do with it? So Bulbrook 1, as we know, is completely destroyed. There's nothing left. The gravel pit took care of it. But we still have potential extant parts of Bulbrook 2. And we also have a lot of environmental aspects we can look at. And in the age of technology, we have a lot of computer modeling and remote sensing that can be done to maybe try to help answer some of these questions. So one thing that I did recently for school was a suitability model. This was done very simply. I literally only based it on Bulbrook just to keep it simple. And I took 5 environmental parameters. This was slope, aspect, distance to linear water features, distance to water bodies, and superficial geology. I converted each of these data sets into a raster format where each cell was reclassified, the number between 1 being high, meaning high sensitivity for an occupation, and 5 being absolutely not. It's marsh, no one wants to live there, so that would be a no. So each cell could have a value of no less than 5 and no more than 20. And then here we have anything between 5 to 7 is considered high, 8 to 10 is considered moderate, low would be 11 to 15, and no is 16 to 20. And again, this is also first order approximation. So I'm not taking into account the Pleistocene landscape. I'm literally just using modern data sets to create this model. And so then you reclassify. So here, for example, is a reclassification. I'm sorry, this is the superficial geology for a 10-mile radius around the Brook 1 site. And then here we have it reclassified. So you can see high sensitivity is red, moderate is green, low is blue, and then no is in yellow. So that was an example of one of the data sets. Then we combine that, all 5 of those into one, and we get this final model here. So that areas considered to have high sensitivity that could have similar paleo aggregation sites were 11.5% of the total model. So that's again values 5 through 7. And this follows a normal deviation curve. It indicates that values within the center of this distribution are very close to random and we're not diagnostic of preferred aggregational landscape. So that would be these peaks here. It doesn't mean that there's no aggregation site. It just means that there's no special consideration with regards to landform when if it was occupied. The end members here on the curve indicate they are incredibly rare and suggest that certain landforms are being preferentially selected based on certain criteria, and they are in fact would be very rare. So then similarly, end members on this side signify no possible occupation of these landforms. And then that's basically what this image is showing you, just in a prettier picture than a table. So I'm hoping to expand on that suitability model. I'm also going to look at caribou species distribution modeling. So they've done this quite a bit in Europe, although I haven't seen much done here in the States. But ideally, you do something very similar where you look at all these environmental layers, you look at how a species distributes itself across a landscape, and then you get a potential current distribution, and then you also get a potential Pleistocene distribution by trying to import these ideas about what the landscape looked like. And the idea for that is to try to identify places where caribou may have been across the Northeast during the late Pleistocene using these environmental data. And then with that, we can use something called Circuitscape. And Circuitscape uses algorithms from electronic circuit theory to predict migration routes in similar landscapes. So the cells in a raster are attributed to a resistance value that's probably like a landform that blocks movement through an area. And then you use least cost corridor analyses and circuit theory to basically map where animals could move about. So this example here from Asia shows snow leopard movements where the blue-green represent probable dispersals and the red-orange are low probability. And then black hashed are core habitat areas. So ideally it would be something we could try to model how caribou not only were moving across the landscape, but then where high probability of movement could have been. And we can apply that to our suitability model and other paleoindian sites within the region and just see how they all match up together. Also plan to do some geophysical and remote sensing surveys. So on the left here, we have an example of a digital elevation model of, God, it's not that recent now with the pandemic, but it was a UNH field school at a 17th century garrison site in Durham, New Hampshire. And the drone was flown and then the DEM model was created. And what it does is it gives us this really nice high resolution picture of the surface of the ground. And we can hopefully use that then to identify parts of the landform that seem really attractive. An example or comparison, I should say, is this one on the right. This is also a digital elevation model from LiDAR. You can see it's a lot more, it's not as well defined, and that's because this is coming from satellites. The one on the left came from a drone. So ideally, if we fly the drone, we should get better detail of the landform itself. We also did do a very preliminary GPR survey of this landform. So you can see these are our track lines here. We're just checking it out, really. But we're hoping to do something similar across the salt marsh here, mostly because it's non-destructive. We could, try to do some kind of salt marsh core, but that then you're, trampling on grasses, you're coring into the ground, and it just becomes kind of messy. So a GPR is a nice way of just remotely sensing, and we can hopefully get a sense of what beneath this marsh looks like. We also had some magnetic survey done. I went back in 2014, I think. So the magnetic, anything that's green is negative. So means no alteration to soils. Red are positive magnetics, which are typical readings for archaeological features. Heavy green and heavy red pairs or dipoles, as shown in feature B here. If orientated a north-south, they indicate iron or historic features. Feature C, which is red without a green dipole, suggests archaeological magnetics. So this again was also very preliminary. You can see we only did 2 little sections of the landform, but it gives us a sense that the landform at Brook 2 is relatively pristine. There's not a lot of historic alteration to the soils themselves. We do have an iron fence out there, so we may have been picking up, that might be actually what B is. But other than that, it's not very noisy, so it's indicative of a nice, pristine landscape, which, as you know, in New England can be quite rare. And so each of these methods are designed to further the understanding of the paleoenvironmental characteristics that made Brook seemingly unique, but also contributing new information pertaining to the seasonality of the occupations and resource acquisition, hoping to refine the relationship between the 2 sites, and then really the suitability model to try to figure out where other Brooks could be located within the region. And then contribute to the overall regional mobility patterns of Paleoindians. And yeah, I think that's all I got. I think I went really fast.
No, it's perfect. So, if people want to send questions in, we can go through and do that. But I'll start. I always ask every speaker sort of the same question. What got you interested in the subject, in like Paleo-Indian studies and everything?
It was scrap. It was 1997, and that was the first year they worked on the Israel River Complex in New Hampshire. So I kind of fell into it by accident, and just by being a part of the field school program, which is a magnificent program, and I highly recommend it to everybody. And then I supervised the field school in 2004 and ended up finding the Potter site. So when I had gone to Orono, my intent was to do the Potter site, and Brian was like, "That's great, but I have this other project I'd really like you to work on." So it worked out well.
Brian could have talked to anyone.
Yeah, it didn't take long for him to talk me into that. I mean, who would pass up an opportunity to work on such a site, you know?
Speaking of that, if you don't mind spending just a few moments talking about Chris Conley and what they just did with the land.
Yes. So if folks are not aware, we just recently completed, I think actually in January. It feels like recently, but this has been a weird year. But I believe January it was finalized. The Archaeological Conservancy has completed the purchase of the Connolly portion of the Brook 2 kind of area. So that's very exciting to have at least part of the site now preserved, which is fantastic. So,
Okay, so our first question is, has any dredging on Jeffrey's Ledge found evidence of caribou or other such critters?
No, I know that UNH has done some work looking at the surface of Jeffrey's Ledge, and there is a lot of impact from scallop dredging and things like that. So I know, like, when Brian and I talked about it, the potential of looking at Jeffrey's Ledge, which is just kind of out of the scope of my project, we would have to put some kind of core in to try to find something intact. And whether that was possible or not remains to be seen, because, you know, no one's been able to get out there and do it. But it has been impacted by, I know you can actually see like drag marks from the scallop boats. And then I'm blanking on the professor's name at UNH, who has done, Larry Ward, has done a ton of work out in the Gulf of Maine and on Jeffrey's Ledge, doing really nice high resolution mapping. And they've done some really great work. They had a poster at an NEGSA within the Raleigh River, which is the river that comes out into Plum Island estuary, and the Egypt and Muddy rivers that are on either side of the Bulbrook landform form the confluence of the Raleigh. So they've done some work in there, and that was actually how we have the dates for the Holocene salt marsh creation, because they had done some coring out there to kind of establish that timeline, which has been great. But yeah, there's I think more of the computer modeling is going to hopefully, I don't know if it's going to definitively answer the question, but I think it will just put us in the right direction. It will give us a sense of where they may have been at George's Bank. There's a lot of other places that the refugees could have been located, considering there was a lot of available land at the time the site was occupied. Just the convenient location of Jeffrey's Ledge, so close to Cape Ann, I think has always been kind of the focal point, but it's all still kind of speculative.
Okay. Our other question is, what are the reasons to think Bulbrook 1 and 2 were occupied at different times, or alternatively at the same time?
So the morphology of the lithics themselves, we don't have the same diversity at Bulbrook 2 that we have at Bulbrook 1. So they just look very different, not only in how the locusts are oriented. They're really tightly packed. Some were overlapping. I think there were two that had to kind of like a question mark, because they're just might be not real. And then I think locust E might be like two locusts combined, because it just was so large. So it doesn't have the same discreteness of patterning that we see at Bulbrook 1. We also have very different we have similar tool forms, but again, we're lacking those drills and flake shavers that were at Bulbrook 1. Although I think Bulbrook 2 might have like a couple flake shavers, but not in the same, like, there was a lot at Bulbrook 1. And then of course drills, there was a ton of those at Bulbrook 1 as well. So we're not seeing the same tool diversity or predominance of lithic material between the two sites. So they just look very, very different to each other. The tool typologies are very similar, so we feel that they are within the same time frame, but we can't definitively say, based on the data we have, that they were occupied at the same time.
Okay. We have a question on vegetation. We know what the dominant vegetation types were during these occupations?
I think it's like a pine mixed forest in southern New England, the time the site is occupied. And so, yeah, you'd have a lot of pine, I think oak, kind of your typical folks around for tree species. It would have been a little bit colder, so I think you would have had more of the kind of the pine dominated forest, but it would have been mixed woodland.
Okay. Well, those are the questions we have. Thank you, Jen, for joining us today. And everyone else, please join us next year in January 27th for our first episode of season 2. So thank you everyone for joining us.
Yeah, thank you everyone for coming.